Hello and welcome to another conversation with the team from EAR. And on this episode, we're going to discuss what performance per watt actually is and why it's so important. But before we get into the conversation, I'm going to ask Julita, who is EAR's Chief Technology Officer, to give a quick introduction.
Yeah, sure. So my name is Julita Corbalán, and I am the CTO of EAR, the Energy Our Solutions company. And I am also associate professor at the Polytechnic University of Catalonia and associate researcher and the team leader in Barcelona Supercomputing Center, the National Supercomputing Center in Spain.
Awesome. So what does performance per watt actually mean?
So performance per watt means that you get the best ratio between these two concepts. So performance reflects performance is the metric, is the generic metric that refers how fast your application are running. It's not always execution time, but anyways the default metric. In some other cases there are like new metrics like images per second or whatever. Anyway, it reflects the computational activity of your applications, your jobs. And batch is the metric for power consumption. Okay, so in the past there was many software focusing only on performance, and this is in fact the target of the CPU and GPU vendor is running as fast as possible, targeting energy efficiency. In some of the cases they were addressing power consumption. Our philosophy is to get the best ratio, the best relationship between what you get and the power that you consume to get the results. So it's not running as fast as possible, it's not consuming the minimum, it's getting the maximum performance with the power consumption. So you're running the best operational configuration for your infrastructure, for your data center.
Cool, but why should CEOs actually care?
Well, in fact, it's the metric they should care about, because when you buy a new data center or when you already have an infrastructure, there are two main sources of cost. One is the cost to create the data center, the infrastructure itself. Well, there is not only about the computing system, there are other things like storage, network, cooling, and so on. And then there are the operational costs. Okay, so with a software like EAR that automatically adapts the configuration of your data center to your workload and to your hardware, because it's these two angles. What are you running at the infrastructure that you are running on? Okay, so what you do is on one side you maximize the benefit of the infrastructure you pay for. Okay, so it's really sad when you see a new data center that is not really running at the maximum. And it's not about utilization, because utilization is a very ambiguous metric. It's about performance. It's the activity, the real activity that you are generating. Okay, and then it's also I would say it's also a pity when you in terms of the operational cost, when you are allocating, for example, power or resources to applications or workloads that they are doing a very bad utilization of the resources. So, for example, we see use cases where there are jobs running for, I don't know, 1 week, and then having a very, very low utilization, or allocating a lot of GPUs for nothing, for mostly nothing. Okay, so that means that the CEO of the data center, they are losing money. And probably this is what they will, the main thing they will care about, that they don't want to lose the money, and they don't want to pay for something really expensive that they are not really using intensively.
So we touched on this a little bit earlier, but do you think that performance per watt will become a standard KPI in the future?
Performance per watt has to be the KPI. What is a little bit complex is to have a single metric. We have to understand that it's a complex problem. We have many scenarios, many different workloads, many different architectures. So what is not possible is to simplify performance in a single metric. That will not be possible. So performance is a little bit more complex. Even for a same scenario, the performance is, in fact, as we do in EAR, our signature is not a single metric, so it's a set of metrics. So you have to understand that, for example, there are applications that there are input-output intensive, so data intensive. So for these applications, for example, floating point operations is not the metric. Okay, it will be maybe accesses to storage per second, or there are some applications doing image analysis, so the performance is images per second. So what it will change is the detail of what performance means on the different workloads context, data centers, and so on. Okay, but performance per bug is the metric. But again, performance is what is the activity of your application is doing, and then if we select the set of metrics, will not be 100 metrics. I mean, it will be 3, 4 of them, because at the end there are derivative metrics. Okay, so there are. It's not metrics as we say in raw. It's not directly from the sensor. It's metrics that we have already pre-processed and convert or something that means metric that has a meaning. For example, as I said, instructions per cycle, for example, which refers to the number of instructions you finish per unit of time. For example, this is the classical for CPU. Okay, in the GPU there are similar things, but in GPU is more related to this activity counters that they have. Okay, so performance per watt is the metric, yes, not a single metric. It's a set of metrics, which is a kind of picture of what the application is doing at every moment. So regarding memory accesses, GPU, CPU, storage, and so on. So with that, you can say that it's having a good or bad performance. Okay. So what we have to do altogether is to specify which set of metrics are the signatures. Okay. And how we convert that in something that is good or bad performance. So there is some complexity, but I think we are going in the right direction.
Okay, so that is it for this week's episode. So thank you very much for watching, and please give us a like, a subscribe, or a follow. Thanks a lot.